Hello everyone, my name is Dávid, and I've been working at Meta as a software engineer for over 2 years now. I have worked on a couple of interesting things at the company, like GraphQL and now Slick, our SLO tracking platform. Today I'll be presenting together with my colleague Filip, who will do his introduction a bit later on. We are particularly excited to talk to you about how we are using Slick to improve reliability culture at the company. Okay, but why is reliability even important? Well, we have over 3.5 billion monthly active users across our family of products. These users have various expectations, like they expect that the app is available, the latency is good enough, and they might expect that the data is fresh. Meta is a very complex ecosystem where our apps talk to some backend services. These backend services talk to even more backend services, some of which might depend on some databases. Altogether, we have over 1,000 services across 18 data centers. In this complex environment, it's very hard to meet our users' expectations. In the extreme case, failure in just one backend service can cause cascading issues, affecting the user experience. It is very important that our individual services are reliable, so that our apps are reliable as a whole. Okay, now that we understand the user expectations a bit better, let's talk about how we measure our performance against them. The industry standard way to measure expectations for services is to use SLIs, SLOs, and SLAs. SLIs, or service level indicators, are high-level user-facing metrics like availability or latency. CPU usage or memory footprint are not good SLIs because they are not user-facing. SLOs, or service level objectives, are long-term goals over SLIs. For example, 99% availability over a month could be an SLO for one of our services at the company. And then finally, SLAs, or service level agreements, are contractual obligations in order to meet a set of SLOs. These are mainly used by cloud providers, and they're not really applicable to most of our services at Meta. So in this talk, we're going to be focusing on SLIs and SLOs. Today, Meta is using SLIs and SLOs in order to track our long-term reliability, but this wasn't always the case. In the remainder of this talk, we'll share some historical obstacles that we had with SLO tracking at Meta, how we have solved these challenges by building a tool called Slick, and what was the impact of this work. All right, let me start with some historical context. Imagine that it is currently 2018, and there's an incident affecting the Facebook app. Some users might be seeing some errors due to this incident. And this is horrible. This means that our users cannot see dog pictures. And sure, this is a humorous example, but on a more serious note, users are relying on our apps to talk with their families, and they might be using other very important features like safety checks. As a result, it is crucial that we mitigate this incident, and it is equally as important that we follow up with the affected services to make sure that they improve their reliability as a follow-up. Well, let's say that this incident from 2018 turns out to be very complicated, and we need to talk to multiple service owners to follow up with them. In 2018, there was no unified approach to SLO tracking at the company. This is what the state of the world looks like. We might be talking to one service owner who is using a custom dashboard to track their SLOs. Upon talking to another service owner, they might tell us that they're using a different custom dashboard to track SLOs, in addition to publishing their list of SLOs in a document somewhere. Okay, let's talk to one more service owner. Well, this service owner might tell us that they are publishing their list of SLOs in the wiki, and they're using a spreadsheet to track SLO violations. And then finally talking to one more service owner, this service owner might reveal to us that they're using a monitoring system to track SLOs. Honestly, it was a pretty good workflow, but one of the main problems was that our monitoring system at Meta only provides 2 weeks of full granularity data retention. So this service owner was really struggling to retrospect on their SLOs over the long term. At the end of 2018, things got to a point where people were using all of these different tools to track SLOs. Some teams were even using every available tool at the same time, or what is worse, some teams were using none of them at all. This caused a lot of issues. First of all, there was no easy way to discover SLOs. As we have seen in the story that I was telling, we had to talk with the individual teams to find out where their SLOs lived. We were also over-focusing on the short term. As I mentioned before, Meta's main monitoring system only provided 2 weeks of full granularity data retention. It was very hard to use SLO data to drive longer-term reliability projects. And then finally, SLIs and SLOs weren't really surfaced as concepts in our standard tooling. For example, when you were on call, there was no easy way to see your SLOs. This caused a lot of fragmentation. And now I'm handing over to Filip, who will talk about how we have solved these problems in Slick, and he'll also show some cool visualizations from the tool itself.
Thanks, David. My name is Filip, and I'm a production engineer. And production engineers at Meta are hybrid between software and systems engineers. We focus on making services reliable, scalable, performant, and secure. One of the reasons why I joined the SLIC team was knowing that I'll be working on a platform which enables everyone in the company with making their service more reliable. Let's jump back to 2019 when we started building SLIC. Let me give you a high-level overview of how SLIC is solving problems Dávid was talking about. Let's start with the first problem. The lack of discoverability. This was only magnified by the scale of Meta. Thousands of services, hundreds of themes being scattered across different tools. We have built a centralized SLO index, which can be used to look up for SLIs and SLOs of any service on board to SLIC. Service owners can use it to find SLI values of a service they're interested in using. Another interesting pattern of usage we have seen is service owners looking at how services similar to theirs have their SLIs and SLOs defined. This means that teams can now learn from each other, and we are fostering a collaboration culture. Using the SLO index is easy. And in this example, we can see a search in the index in our UI. The index was not available before, and service owners can now use it to easily search for SLIs and SLOs of services. In order to make this index useful, we had to get services to onboard. This was challenging, but we'll talk about it more later on. So as was already mentioned, Meta's standard monitoring infra offers up to 2 weeks of full granularity data retention. 2 weeks wasn't sufficient. Service owners couldn't use the data to retrospect on longer-term reliability. To solve this problem, we have built a storage layer in SLIC which offers up to 2 years of full granularity data retention. Let's jump back to our UI again. In this example, we can see the SLI data for P99 latency SLI of a service. We are looking at a period between January 26th and February 14, 2021. In the bottom left chart, we can see that this SLI has full per minute data granularity. In the bottom right chart, we can see the motivation of service owners to look at this specific period, because they wanted to retrospect on when and how they started meeting their SLOs. Let's now talk about how to actually get users to this UI. In order to easily navigate our users to our UI, we had to solve the fragmentation problem. Fragmentation was painful because service owners had to take manual steps to get SLO information. For example, they might go to the wiki where their SLOs are defined and go to charts from there. This was taking time away from engineers. SLIC integrated various operational tools to surface SLO data. So for example, on-calls can now easily see their SLIs and SLOs in their on-call tracking tool. Let us give one concrete example of integration with SLIC, which is from Workplace, our collaboration tool at Meta. We have built a bot which periodically posts in workplace groups about how services are performing against their SLOs. This is important for the social aspect of SLOs because people are using these posts to discuss reliability regression and often brainstorm about ideas on how to fix them. And in this specific example, you can see two very serious engineers discussing a recent reliability regression of an example service. And David, I think this is us. Solving all these problems at meta scale was hard. And now David is going to talk more about how we build the index, how we solve the retention problem, and how we enable the seamless integration of SLIC into service owners' workflows.
Thanks, Filip. Building SLIC was very interesting due to the complex challenges, and it was exciting for our team to solve all of these. Let me explain how we did that. Service owners can onboard to SLIC by defining a SLIC config. This schema standardizes the process of defining SLOs at the entire company. The query field here specifies how to fetch SLI values from Meta's data info tools. The specific query here is not that important because it's custom to Meta's monitoring systems. SLIC allows defining two kinds of SLOs, advertised objectives and aspirational objectives. Advertised objectives are the SLOs that are visible to the users of a service, whereas aspirational objectives are more internal to the teams which own the services. Aspirational objectives are more strict, and they represent the reliability that the team is currently striving towards, but they might not be hitting consistently just yet. Following the industry standard, SLIC supports both success ratio and time-based SLOs. Alright, now let's see what happens once service owners have finished writing their SLIC config. I'm going to be presenting SLIC's overall architecture through a couple different user workflows. The first workflow is authoring and editing Slick configs directly. Once the service owner has finished writing their Slick config, the config gets picked up by the Slick syncer. The Slick syncer extracts the config metadata into a database, and we are exposing this database via an object relational mapping so that we can easily access the config metadata programmatically. The second workflow is using the Slick UI. The object relational mapping that I was talking about just now has information about all of the Slick configs, and this powers the SLO index in our UI along with the search. This is how we have solved the discoverability problem. Service owners can also edit their configs from the Slick UI. Some users might prefer to edit the configs directly, and some of them might use our UI instead. The Slick UI talks to the Slick service via a GraphQL wrapper. The Slick service abstracts away all of the SLO computation logic and can answer questions such as, what was the value of this SLI over the past 6 months, or has this SLI been meeting its SLO? The Slick service answers these questions by querying a time series database. We are populating this time series database by data pipelines that run periodically. This is how we have solved the retention problem. I'm going to talk about this in more detail very soon, but first let me talk about one last workflow here, and that is using the Slick CLI. The Slick CLI has a bunch of different available commands. For example, you can use it to backfill your data in Slick, or you can test the effect of changes on Slick configs. The CLI is a very thin wrapper around the Slick service, and the report that Filip showed earlier and other integrations are also using the Slick service. We have solved the fragmentation problem by providing this Slick service and allowing easy integrations with Slick. Alright, as we walk through the architecture, we've seen some of the major user workflows, and we have also seen how Slick solves the 3 problems that we talked about earlier. We have addressed the discoverability problem by building an object relational mapping from the Slick config metadata and using this to power the SLO index. We have solved the retention problem by running periodic data pipelines to persist the SLI time series data over the long term. And finally, we have enabled easy integrations with Slick by providing a Slick service. I personally think that the most interesting part in Slick is the data ingestion, so let's talk about that in more detail. So now I'll explain how Slick provides the 2-year retention guarantee. Meta's one-chunk systems store billions of time series. We cannot possibly persist all of this data with the full granularity for 2 years. Instead, we need to be very selective in what we are storing. The Slick data pipelines are taking the subset of the metrics that are used in SLIs. This is determined based on the Slick config metadata DB that we have seen previously. We are using a sharded MySQL database as our storage layer in Slick. The shards are identified by a shard map that knows which SLI's data is stored in which shard. The full granularity SLI time series is written to the shards periodically by our pipelines. And then finally, we have some data quality checks on the entire shard map to make sure that Slick has ingested the right data and that there are no bugs in our persistence layer. And now over to you once again, Filip. Sure, we have built all of this stuff, but was it actually useful?
Thanks again, David. Oh, of course building Slick was useful. Now I'm going to give some stats around Slick's adoption and give few concrete reliability improvement examples as a result of introducing Slick at Meta. We have over 1,000 services onboarded to Slick. Some of this was organic growth due to people seeing how useful SLOs are, but we and our partner teams drove several reliability programs in the company to get people to onboard. 80% of the critical on-calls have their services onboarded to Slick. These on-calls are maintaining services which are very important to keep Meta running, and examples of such services are core networking, Tau, or MySQL. It was challenging to define SLOs for these complex systems, but it was worth it. SLOs have had a large cultural impact because they force teams to think about which metrics are important to them and to their customers. One of the complex systems using Slick is LogDevice. The LogDevice team manages critical log storage infrastructure at Meta. And in this chart, you can see historical reliability for LogDevice. It's important to note that we are using slightly altered mock data to preserve confidentiality, but the chart shape matches what's in production. At one point, LogDevice started regressing against their goal of 4 nines of availability, and this impacted one specific customer. With Slick, they were able to quantify both the amount of regression as well as how effective their recovery efforts were. Since then, they still rely on Slick to track their performance against their SLOs. LogDevice is only one of many success stories we have seen. Another story we'd like to talk about is how one of the main feed ranking services in the company started violating their availability SLO. Once again, we are using slightly altered mock data, but the chart shape is the same as in production. Slick data consistently showed that reliability of ranking drastically needed improvement. The data was quantifying the pain that was felt across many products relying on this service. The ranking team held a series of reliability reviews. They looked at this data, investigated possible issues, and created a plan to recover. The ranking team started meeting its SLO after some time and surpassed the goal afterwards. The team turning things around is a huge point of pride for the org. It was really exciting for Slick team to hear these stories as well, knowing what we have built has contributed to these significant reliability improvements. And now, going back to the example from the beginning of the talk, specifically on how complicated it was to talk with service owners about reliability in the company. As we have seen in the success stories, people are now using SLOs and Slick to track long-term reliability. And now, if a similar incident happens, the discussion looks differently. Here we can see a quote from an incident report for a recent outage. The author here used SLI and SLO terminology to conclude that an incident was mitigated. And this is just one example of how SLIs and SLOs are parts of conversations in the company. As different teams started speaking the same language, SLOs became a part of our culture. Let's mention a few important takeaways from this talk. Reliability projects at meta scale can sometimes take months or even years to complete. Long-term checking capability helps with understanding the full impact of these projects. Also, it helps with understanding the patterns of long-term reliability regression. Secondly, defining SLOs is not enough, and in order for them to really be useful, they need to become a part of the culture so that people are using them regularly in their day-to-day workflows. And finally, as service owners have these high-level metrics, they can work on improving them, which helps them with prioritizing reliability work. But Slick's journey has just begun. We're continuing to invest into Slick to make our SLO culture stronger. Currently, it's hard to see how services are affecting each other's SLOs. For example, there's a service which wants to provide 3 nines of availability, but it depends on a service which provides 2 nines, which causes misalignment. We want to ensure that service owners' expectations are aligned across the entire stack. Secondly, as many people are now using Slick, we want to evolve Slick into something that is much more than a tool to track SLOs. We would like to give insights to people on how they can improve their reliability based on our past experience. And finally, we would like to have many more services on board to Slick, so we are working on scaling our backend 10x. This is especially important because Meta is growing. For example, we have recently announced that we are hiring 10,000 people in the EU. We are really excited about this growth. We hope you enjoyed the talk, and thank you for listening.